Hello, class. In this example, we are going to apply this variation of parameters, but this time the difference being um, using an integral defined function. So I have here a second order differential equation. Y double prime minus y is equal to 1 over x, which is already in standard form. We don't need to do anything to it, which is nice. We could form the auxiliary equation from this. M squared minus 1 is equal to 0. And that gives us two nice solutions. Well, this gives us two nice solutions. M sub 1 is positive 1. M sub 2 is negative 1. They're real and distinct. A complementary solution to the associated homogeneous differential equation is C sub 1 times e to the x plus C sub 2 times e to the negative x. We could calculate the Wronskian from this that we would do for the variation of parameters. This would be e to the x, e to the negative x, e to the x, and negative e to the negative x. So multiplying this and simplifying from what we have, this gives us a nice value of negative 2. So u sub 1 prime is going to be negative e to the negative x times 1 over x divided by negative 2. And u sub 2 prime is going to be e to the x times 1 over x divided by negative 2. So both of these, we could try to integrate to find the values for this so we could form our solution. But for u sub 1, this would be 1/2 times the integral from, this is going to be x sub 0 to x of e to the negative t divided by t, dt. And unfortunately, we can't integrate that at all, right? Likewise, because of that, u sub 2 is going to be negative 1/2 times the integral from x sub 0 to x of e to the t divided by t, dt. Likewise, also can't integrate. So our particular solution for this, which I'll just write over here, try to squeeze in there on the bottom, y sub p is going to be the combination of these two. So 1/2 times, I'm going to factor out and eat, yeah, so for this, we're going to take the two integral defined solutions that we have times the associated values. So u sub 1 times y sub 1 will be 1/2 times e to the x times the integral from x sub 0 to x of e to the negative t over t dt. I'll continue this down here. Minus 1/2 times, again, e to the negative x for u sub 2 times y sub 2 times the integral from x sub 0 to x of e to the t over t dt. And then we could combine the whole thing into our complete general solution for this. Y would be complementary plus particular solutions. So c sub 1 times e to the x plus c sub 2 times e to the negative x plus 1/2 e to the x times the integral from x sub 0 to x of e to the negative t over t dt minus 1/2 times e to the negative x times the integral from x sub 0 to x of e to the t over t dt. So let me know if you have any questions or concerns. Thank you.